Now, another area I want to talk about is that Copenhagen, uh, the Copenhagen interpretation of double slit. Now, if you watch about the first 20 minutes, of this, where Brian Greene so elegantly explains how the double split works, he also gets real excited about the scientist cut. He also gets very excited about the Louis de Broglie interpretation. Now, as you saw in that other video, Louis de Broglie didn't originally have that interpretation. He got talked out of it at one of the conventions and got into the Copenhagen experiment, interpretation. But Greene seems to think that's the greatest thing since apple pie. I don't. I say go back with de Broglie's original pilot wave theory. And then when Bohm came along, B-O-H-M, Bohm came along, they kind of improved on it. And then I think I've improved on it by adding the space-time energy particle concept to be the hidden variable of the whole thing. So the only thing I want to say, or one of the things I want to say is, yes, Brian Greene, you are a very intelligent man. I've read your book. I've ripped it apart practically, trying to understand all the wonderful things you've said. But believe me, keep an open mind on this. This Copenhagen interpretation is not too solid. You got all this spooky action going on. And it's not like it's not the reality that Einstein talked about, or that the common man who looks at the moon and figures it's still there when he looks away. The peekaboo universe is not the way we want to go, Mr. Greene. And I sure respect your intelligence, but how about thinking this one over again? Cut.
Yes.
Now, Michael Kako explaining the string theory in many of his videos, and here's one 4-minute example of some of the concepts he believes in. Now, Mikio is a very intelligent man, and should be given a lot of credit for his contribution to the scientific world in terms of theoretical physics. But there are a couple points that he's made that might want to be rethought. Now, one of them is when he keeps saying that Einstein's equations break down. Now, in this particular one, he said it breaks down in the black hole as well as before the Big Bang. Well, what I'd like the scientific community to understand is to go back and see what Planck said. Max Planck was working with black box radiation, and he couldn't get it to work in all of the radiations until he came up with a fudge factor. And once he got that fudge factor, everything fell into place. And now it's in most of the theoretical equations as being the Planck's constant. Now, that Planck's constant can also be utilized in the understanding of the universe in a big, big way. You got to understand, when you take you make a brownie, okay, it's 8 by 8, and you cut it into 4 by 4s, and then you cut that into 2 by 2s, and you figure let's go to infinity. Well, pretty soon the brownie will be bigger than the edge of the knife. The thing is, when it gets so small, the universe stops at the Planck's cubic dimensions. So anything smaller than a Planck's cube is not in our universe. As a matter of fact, if you want to talk about multi-universes, let's call these space-time energy particles universes. And that would be a multi-universe, wouldn't it? When if you read my book, I say there's maybe 10 to the 183 plus or minus space-time energy particles in our observable universe. Okay, now that addresses the many worlds concept, but in a different way. We're not going into that when you drink a glass, like Brian Greene would say, in our universe, it might be green, in another universe, it might be red. No, those other universes, if you want to call them universes, are there, and they all have wormholes in them, like I explained just a minute ago. Now, that's one area where, Michael, I disagree with. So forget this breaking down, equations breaking down. They just go to a small size. Now, in the string theory, Seskin says that the largest possible number is maybe, and he's not sure of it, 10 to the 500. So these could be the two limits of our universe. Those two limits, large and small. And we can forget about infinity. In my opinion, infinity is reserved for the eternity. Eternity might be an infinite, we don't know. But certainly our universe, and many theoretical physicists agree, is not infinite. And that also, the other side of it is you don't divide by zero. And that's where you get infinity. Mathematicians will tell you if you divide by zero, you get infinity. Well, zero and infinity aren't even part of our mathematics. They're just symbols. And so keep that in mind. Now, the other thing that, two other things that Michael states is one small little item was when he said that all the theoretical physicists are imported from beyond the United States. I just like to remind them that Seskin and Garrett Lisi are not imported, and I think they make a great contribution to our scientific community. But the really big thing I want to talk about is him saying that all our equations should be reduced, or the theory of everything should be reduced to one 1-inch equation. Now, in my first book, I have that 1-inch equation, and I've been looking and looking to find it in Michael's videos, and I haven't found it yet. But if he hasn't found it, I think he should look at mine. I'd love to get feedback from you on this subject and tell me where I'm going wrong. I'm putting this out there so you guys can straighten it out. Everything in my book, in terms of math, I round off. I don't say 6.0 times 10 to the minus 34th or anything like that. I just say 10 to the minus 34. I round everything off. Now, I think if the mathematicians of the world would put the real numbers on, they may even refine what I have in my books. And they may even find things that could be postulated based on the way I see the universe. And so I thank all these great scientists for what they do, but I think that we need to a fresh look at the Copenhagen interpretation, as well as a few other things. Now, there's a couple other things I want to say before we close this up. Now, Garrett Lisa is a very interesting scientist, and I don't think he gets the credit he deserves for what he's put forth in his theories. The only one thing I'd say about his theories, I wish he'd change a little bit, is that he calls the elementary particles point particles. And I would like to recommend that he think of them in terms of string particles. And if he puts the string particle theory along with his E8 dimension, I think he's on his way to making a major contribution to the science, and I do mention it in my books. So he's one of the up-and-coming stars of the 21st century. Now another great scientist is Susskind, and Susskind was a founder of the string theory along with many other things, the heliographic concepts, and he talks about the cosmological constant, which, as I said earlier and in my book, that the 1-inch equation that I have says that the eternal force equals the cosmological constant acceleration times dark matter, and as those things change in the equation, the universe develops. Now the cosmological constant, as Susskind denotes, is of huge implication that the universe is created by a creator and not just by accident. Now this is where I think Susskind is in denial. Susskind still wants to go along with many worlds theory and antitropic concepts in landscape, he calls it. Well, I think he's in denial, because the more he learns about the cosmological constant being refined to a tune of 10 to the 120 power, those things just don't happen by accident. He knows it. Leonard, you know I'm right. Come on, get off the kick. He's a great scientist. Anyways, my books, you've seen them before. The Einstein Me and the Grand Original Design, and Granulation of the Observable Universe. It's all packed in there. Plus these videos, I've said a few extra things. I made a few discoveries based on what I know in these books. I want the scientific community to run that experiment, and you find that hidden variable, which is the time channel. We'll be on our way. We'll be on our way. God bless you. I hope somebody out there heard me. Thank you. Have a great day.